Hi everyone, welcome to another daily problem set. In this today's episode, we're going to go over some calculus problems. So the first one is, for which values of x is the function f of x equals x cubed minus 4 over x squared plus 5x minus 5 continuous? So for a problem like this, all we're looking for are places where the function is not continuous, where it has holes or asymptotes or just gaps in the function. And so for this one, the only thing we have to pay attention to is this component right here, the 4 over x squared. And the reason for that is that none of these other components affect the function in this way. They only make the function more positive or shift it in some way. 4 over x squared, though, when x equals 0, it makes 4 over 0, and that's not defined. So we know that the function f of x is defined for all values of x except for x equals 0. And so we can just write, we can write this in this sort of notation, so negative infinity to 0, and then parenthesis because we're not including 0, and then from 0 to infinity. We could also just write it's defined for x not equals 0, and that works too. Moving along to question 2, here we're just going to take the derivative of f of x, where f of x equals 5x squared times cosine of x. So this is a little more complicated than just taking a straight up derivative, like if we had f of x equals 3x squared, for instance, because we've got two functions that are being multiplied together. So we need to use the product rule here. The product rule states that the derivative of two functions is equal to the derivative of the first function, maybe I'll write, f prime of x, times the second function, plus the derivative, or plus the first function, times the derivative of the second function. So for this function here, we can just rewrite it as such. We can go, the derivative of f of x is equal to 5x squared, the derivative of 5x squared, times cosine of x, plus 5x squared times the derivative of cosine of x. Well, what's the derivative of 5x squared? That's just 10x. Plus 5x squared. And then what's the derivative of cosine of x? Well, it's just negative sine of x. So our derivative, finally, is 10x cosine of x minus 5x squared sine of x. And that's all we have to do. Moving on to our third and final question, we're going to calculate the radius of convergence of this power series. So we're going to use the ratio test for this. We're going to start by rewriting. So we have that the limit, we're going by this equation right here, is equal to 3 to the n plus 1 times 5x minus 25 n plus 1 over n plus 1. This is going to be multiplied by n over 3 to the n times 5x minus 25 to the n. Now we're going to simplify this entire expression right here. We can rewrite this as, these terms are going to cancel, so we're going to end up with 3 times 5x minus 25. Basically, the nth term cancels for both of these. Oh, this should be parentheses. Sorry about that. And we are left with a times an n up here and an n plus 1 down here. Now, I should have been including the limit down here, so let me just do that real quick. Let's see. Limit as n goes to infinity. Okay, so now we can factor out certain terms. So these are not affected by the nth term, so we can drag them out. We can rewrite this as 3 times 5x minus 25 times the limit as n goes to infinity times, or actually we can bring out this whole absolute value here, so we can do that. Okay, and this is the limit as n goes to infinity of n over n plus 1. Now this value right here, this simplifies to 1. As n gets bigger and bigger, the difference between these two values becomes smaller and smaller, so the limit as n tends to infinity of n divided by n plus 1 is just 1. Meaning that what we're left with is the absolute value of 3 times 5x minus 25. Now, in order to find the radius of convergence, we just need to find for when it's less than 1. We can factor out a 5 from here, getting 15 times x minus 5 less than 1. Divide both sides by 15, which gets x minus 5 less than 1 over 15. And now 1 over 15 is the radius of convergence.